So, in continuation to the series of lectures on measures of central tendency, today I am here with another measure of central tendency, that is mode, and that I have already mentioned that mode is the positional measures of central tendency. So, next, what is mode? The mode is defined as the value of a series that occurs maximum number of times. That is, the item or value having maximum frequency. So, any data, if you are presented with any data and a particular value is having maximum number of occurrence, then such value is known as mode of that data series. Then there are four computational methods to determine the mode. The first one is the method of inspection. Second one is method of grouping. Third is method of graph, and fourth one is the method of empirical relation. So the mainly we will be focusing in method of grouping. Others are very easy to understand, but this method of grouping is very useful in certain situations that we will see in the next slides. So the first one is the method of inspection. So mode or model class is determined by simple inspection of the distribution. So whenever you are presented with the data, just by seeing the distribution of data, you can determine the mode of that particular data, or you can determine the model class. The value occurring maximum number of times, or the class value against which the maximum frequency stand, is taken as the model value or the model class. So when you are having discrete ungrouped frequency distribution, ungrouped data, so in that case the particular value which occurs maximum number of time, that will be the mode of that particular data. But when you will be provided with the classified data, either in discrete series or continuous series, so the class value which is having maximum frequency, that class value will be known as model class. So the second and the important method is the method of grouping. So just look at this data, the determine mode from the following data. So this is the x value of the data, and this is the corresponding frequency. Now here by simply inspection, you can see the maximum frequency is for two class, that is for the class 10 it is 23, and for class 40 it is again 23. So here by simple inspection, you cannot say what is the model class or model value. So for that you will have to go for method of grouping. So method of grouping is mainly divided into two parts. The first one is preparation of grouping table, and second one is the preparation of analysis table. So what we will do, we'll first see the table, and then we will come to how this table is prepared. So here you can see this is the grouping table. So what we have done in the grouping table, in the first column you write the value. In the first column you write the value. Which value? The x value that we have already seen in the question, that example. So x value is 5, 10, 15, 20, 25, 30 up to 45. So the first you will put the value of x, that is the class value. In second column you write the frequency. You write the frequency in the second column. So corresponding frequency as given in the question paper, the example, the corresponding frequency against 5 it is 11, against 10 it is 23, against 15 it is 70, and likewise you will write the frequency of each class. Now, this frequency column, you designate it as 1. So, this is the first column. You write it 1. Here I have already written 1. This is the 1. So, the frequency table, the frequency column will be designated as column 1. This is very important. You have to write and you have to designate it as 1. Now, you have to group the frequency. Now, you have to group the frequency, and you can group your frequency in either in terms of 2 or in terms of 3. So, how you will group the frequency in terms of 2 or 3, just we will see here. So, you see, the first we have in the second column. So, the column that actually it is third column, but we have designated it as second. So, we have to designate the column as second. In second column, you have to group the frequency in terms of 2. So, what we will do, we will add 11 plus 23. 11 plus 23 is equal to 34. 11 plus 23 is equal to 34. Then secondly, again you have to group next two frequencies. So 17 plus 18 is equal to 35. So this is called as grouping in 2. Similarly, next 20 plus 5 is equal to 25, and next 21 plus 23 is equal to 44. And next the 22, frequency 22 remains alone. So we will just leave it. We will not do anything because we did not get the second partner to add upon. So that is why we left it as such. Now again, the third column, you have to designate the third column. And again here you have to group into 2. But the grouping is different because we are grouping in 2, but leaving the first value. So what we had done in column 2, we had added 11 plus 23 is equal to 34. But here in third column, what we will do, we will leave the first value 11. 11 we will leave. We will not include 11. So what we will do, we will add 23 plus 17 is equal to 40. Similarly, the next value 18 plus 20 is equal to 38. Then 5 plus 21 is equal to 26. Then 23 plus 22 is equal to 45. So this is the method how you group the values in a group of 2. So first you have to start from the first frequency. In second grouping of 2, that is in column 3, you have to group frequency in group the frequency in 2s, leaving the first frequency or starting from the second frequency. Now you have to group in terms of group of 3. So in group of 3, so just in column 4 you can see we have grouped it in terms of 3 values. So first value is 11 plus 23 plus 17. 11 plus 23 is equal to 34 plus 17 is equal to 51. Similarly, the second one 18 plus 20 plus 5. So 18 plus 20 is equal to 38 plus 5 is equal to 43. Then next value 21 plus 23 plus 22. So 21 plus 23 is equal to 44 plus 22 is equal to 66. So this is the grouping in terms of 3 values. Now secondly, again in column 5 you have to group in 3 values together. But what you have to do, you have to start from the second value, leave the first value as we have done in the when we were grouping in 2. So first value 11 you will leave the value 11, and you have to add 23 plus 17 plus 18. So 23 plus 17 is equal to 40 plus 18 is equal to 58. Then similarly next value 20 plus 5 plus 21. So 20 plus 5 is equal to 25 plus 21 is equal to 46. So this is the second grouping, and next grouping 23, 22, but third value is not there, so we will leave these two values. So this is the grouping in terms of 3. Next again in column 6, again we have to group in terms of 3, but starting from the third value. So what we will do, we will leave 11 and 23 and we will start from the value 17. So 17 plus 18 is equal to 17 plus 18 plus 20. So 17 plus 18 is equal to 35 plus 20 is equal to 55. The next grouping 5 plus 20 plus 23. So 5 plus 21 is equal to 26 plus 23 is equal to 49. And the last value is alone, so we will not add. So we have to remember that grouping into in the first column you have to start from the first value. In the second column you have to start from the second value. Grouping in terms of 3, so in fourth column you have to start from the first value, then in fifth column you have to start from the second value, and in sixth column you have to start from the third value. So this is how we are preparing the grouping table. So you have to be very careful. It is very simple, but the procedure should be clear in your mind so that you can prepare grouping table without any error. So hopefully this is clear to you. What we have done. Again I will summarize the procedure. First of all, the value which has been given in the question we will write in the column 1, but we will not designate it as any column. Just this is in this column we will write the value. In the next column we will write the frequency, value of the frequency, and we will designate this column as column 1. Then in the next column, which we will designate as column 2, here we will group the values in terms of 2 and in terms of 2 starting from the value 1. So here you can see 11 plus 23 is equal to 34. Similarly 17 plus 18 is equal to 35, 20 plus 5 is equal to 25, 21 plus 23 is equal to 44, and this last value, because we are not getting any pair, we will simply ignore it. Then next column, that is we will designate it as column 3. So what we will do, we will add the value 23 plus 17. That means we have to group in 2 but start from the second value. So 23 plus 17 is equal to 40, 18 plus 20 is equal to 38, 5 plus 21 is equal to 26, 23 plus 22 is equal to 45. Then after grouping in 2, we have to group in 3. So in the fourth column we have to group into 3. So first start from the first value. 11 plus 23 plus 17 is equal to 51. Similarly we will add all the values in terms of 3. In next column, that is in the column number 5 that we have designated as column number 5, what we have to do, we have to again group in 3 but starting from the second value, that is 23 plus 17 plus 18 is equal to 58. Then similarly 20 plus 5 plus 21 is equal to 46. Leave the last two value because we are not getting the third value. Similarly in next column, that is column 6, designated as column 6, we have to group in 3 but starting from the third value, that is third value is 17. So 17 plus 18 plus 20 is equal to 55. The next value 5 plus 21 plus 23 is equal to 49, and lastly you just simply ignore the value 21 because we are not getting the third group of 3. Now what you have to do, in each column you have to round, you have to highlight the maximum value. So here you can see in the column 1 there are two maximum values, that is 23 and 23. In column 2 we have maximum value as 44. In column 3, we have maximum value as 45. In column 4, it is 66. In column 5, it is 58. In column 6, it is 55. So these values, this maximum value you have to remember, because we have to again prepare the analysis table. Now just simply we will see the previous slides and just read what we have already done. So what it is telling, put the values or classes in the left hand column and their corresponding frequency in another adjacent column to its right. Mark the frequency column as column number 1. So we have already marked the frequency column as column number 1. In column 2, group the frequency in 2 beginning with the first frequency. So in column 2, you have to group in terms of 2 beginning with the first frequency. Now next, in column 3, group the frequency again in 2s but beginning with the second frequency. Again you have to group in 2 but beginning with the second frequency. Similarly, in column 4, group the frequency in 3 beginning with the first frequency. In column 5, group again in 3 beginning with the second frequency. Then lastly in sixth column, group again in 3 beginning with the third frequency. So this already we have seen, and hopefully it is very clear to you. After grouping are over, identify the maximum figure of each of the 6 columns. That also we have already done. So hopefully till this it is very clear to you. Now preparation of analysis table. So for preparation of analysis table, you have to remember our example, that is question. What questions it was asked. So first again what we will do, we'll see the table first. So this is the analysis table. So this is the analysis table and this is the frequency column. So frequency column we have written first 2, 1, 2, 3, 4, 5, 6. So these were the 6 columns. So 6 column frequency column we had prepared the 6 column 1, 2, 3, 4, 5, 6, and we have to write the corresponding probable values. So how we will write the corresponding probable values? So just again we will go to the analysis table so that it will be clear to you. So this is the grouping table. So this is the grouping table, and you can see these are the values which we can from this only you will get the probable probable value. So here you can see in first row there is no maximum value associated with it. So we will ignore the first row. We will ignore the first value, that is 5. But if you see the second row, the maximum value is 23. In third row again it is 58. In fourth row again it is 55. In fifth row, that is 25, there is no value, again it is 55. In sixth row, I think no value is associated. In 7th row, this is 44. In 8th row, again 23 and 44. In 9th row, again it is 44 and 66. Here also it is 66, 44. So I think it will be clear when we will see the analysis table. So we will go to the analysis table again. Just you remember these values can be the probable model values. So we'll go to the analysis table. So here you see the probable model values are 10, 15, 20, 25, 30, 35, 40, 45. So what we have to write? We have to write the probable model values are stated in the top horizontal line under the different columns, and the different column number of grouping table are put at the left side of the table. So already we have done probable model value we have written in the top horizontal table, and the different column numbers of grouping table also we have put it in the left hand side. Then second, the value showing maximum grouped frequency. The value showing maximum grouped frequency in the grouping table are identified by mark in their respective column. So what we have to do? The value showing maximum grouped frequency in the grouping table are identified. So we have to identify the value showing maximum group frequency in the grouping table. So how you will do? We will just see in the next. At the bottom of the table, number of such mark put under the probable value column is totaled. So first we will go again to the table. So this is the analysis table. You see the value 10, probable value 10. So what we will do? Probable value 10. So we will go to the probable value 10. So this is the grouping table. You see the probable value 10. So sorry, this is the probable value 10. So here in column 1 the maximum frequency is there. In column 1 the maximum frequency it is there. Then in second column no, third column no, fourth column no, fifth column it is there. So in the first column and fifth column, first column and fifth column, you just remember the first column and fifth column, and then we will see in the analysis table. So this here you can see in the first column we have put it 1, and in the fifth column we have put it 1, and lastly in the last row we have added these two value, 1 plus 1 is equal to 2. Similarly for value probable value 15, again we will go to the analysis table, grouping table. Here you can see for value 15. So 15 in first column no, in second column no, in third column no, in fourth column no, in fifth column there is maximum value. So what we will write? We will write in the fifth column. So here you can say for value 15, you can get the value in the fifth column and also in the sixth column. So we have ignored, just we will go and again confirm whether it is in the sixth column. So here for value 15 you can get yes in the fifth column, and in the sixth column also there is maximum frequency. So we will write there in the fifth column and sixth column. So you just see what again we have done. We have kept value in the fifth column and sixth column, and lastly we totaled. Similarly for 20 also in the fifth column, in the sixth column. For 25 only sixth column. For 30 no, so it is 0. For 35 yes in the second column and fourth column. For 40 in the first column, second column, third column, fourth column. And for 45 it is in the third column and fourth column. So lastly we will add up in the last row, and we can see here the maximum value we have obtained for the model class 40. So this 40 will be our model class, but this is not mode. When it is not mode, this is mode in the discrete frequency distribution table, but for continuous table this is the model class. For continuous table, continuous frequency distribution, you just remember that frequency distribution, different types of data. So for discrete data this will be the mode, but for continuous, if it is continuous, that is 20 to 30. So which will be the mode? We cannot determine. So this will be the model class. So what we will do, from this model class we will find the mode. So next we will go. So here the heading is interpolation of mode from a continuous series. So when you have continuous series, that means you have value 10 to 20. So So suppose this 10 to 20 is the model class. So what we will do after determining the model class, after when you determine the model class, the exact value of the mode is obtained by applying one of the following formula for interpolation. So what will be the formula? Formula will be L0 plus f1 minus f0 divided by 2f1 minus f0 minus f2 under bracket L1 minus L0. So what is this L0? L0 is the lower limit of the model class. L1 is the upper limit of the model class. Lower limit is 10, upper limit is 20. So lower limit of the L1 model class, upper limit of the model class. F1 is the frequency of the model class. F0 is the frequency of the class preceding model class. That means the class before model class. And F2 is the frequency of class succeeding model class. That means after model class. And if F1 minus F0 you are taking as delta 1 and F1 minus F2 you are taking as delta 2, then this formula will become L0 plus delta 1 divided by delta 1 plus delta 2 into I, where I is again class interval. Class interval. Okay. So this is how you can find the value of mode in continuous series. Now, the third method is the graphic method. So this is suitable in case of frequency distribution of a continuous nature. So you have already seen, if your data is of continuous nature, then finding mode by this grouping method. That means first preparation of grouping table, then preparation of analysis table, and then finally you have to prepare the you have to apply the formula in the model class. So to avoid this cumbersome method, we can determine the frequency mode from the graph, that means by graphic method. So what is the procedure? First you have to draw a histogram. Draw a histogram with a given class interval and their frequency. So whatever class interval and frequency you have been given, you prepare the histogram. The histogram already we have seen in the class of graphical representation of data. Then the highest rectangular bar, the highest rectangle or bar is identified from the histogram. This rectangle is called a model rectangle. So first you prepare the histogram, then identify the model rectangle, that is the highest bar or highest rectangle. Now the two lines are drawn from this model rectangle. So suppose this is the model rectangle, just simply. So this is the histogram that we have prepared and this is the model rectangle. Two lines are drawn from this model rectangle diagonally, starting from each of its upper corner and ending with the nearest corner of their respective adjacent rectangle. So what we have to do, so two lines should be drawn from the upper corner. So this is the upper corner and we have drawn one line to the adjacent column, to the respective adjacent rectangle. So we have drawn. Then second line from the upper corner to the adjacent rectangle. So these two lines we have already drawn. Then from the intersecting point, so this is the intersecting point. So from the intersecting point of these two diagonal lines, a perpendicular line is drawn. So what we have done, we have drawn a perpendicular line from the here up to the base, and this is the value that is on the x-axis. The point at which the perpendicular touches the base is identified as a model value. So this will be the model value. So again we will see with the real graph. This is this I have prepared just to understand. Now we will see the real graph. So this is the data that we have been given. So this is the class 10, 20, 20, 30, 30 to 40, 40 to 50, and this is the respective frequency. And this is the actual graphic method. So what we have done, we have prepared the frequency distribution table, Okay, we have prepared the frequency distribution table. This is the frequency distribution table, and we have identified with this pink mark, we have identified the model rectangle. From model rectangle, from the upper corner, we have drawn a line up to the adjacent bar, adjacent rectangle, and again from the upper corner we have drawn the line from up to the adjacent corner, and at the intersecting point we have drawn a perpendicular to the x-axis, and this corresponding value, that is 36.47, this is the mode. So the graphic method is a very easy method to determine mode in case of continuous series of data. So hopefully it is very clear to you. This was very easy, and there is no problem in understanding it. So you can confirm this. You can confirm this graphic value obtained in graphic method with our old method of calculation of mode, that is by the formula. So this will be the same, 36.47. You remember, this is the formula, and we put all the value in the formula and we determine the mode. So what we had in this was our question. Here you can see the model class. You can see the what was the model class. So model class was 30 to 40. So this is the 30 to 40, that is model class. Now you can put the formula also. So this is the model class. Model class means 30 and 40. So from this model class you can put all the values, corresponding values in this formula, and you will get the value of mode as 36.47. Now the method of empirical relation. So Carl Pearson had given a relationship between the mode, median and mean. So he told that mode should be equal to 3 median minus 2 mean. So this is the method of empirical relation, and this is the based on the relationship among mean, median and mode in case of moderately asymmetric or skewed distribution. Moderately asymmetric or skewed distribution. So this is the formula, and with this formula, if you are having known values of median and mean, you can get mode. Now, what are the merits of mode? So this is for your examination purpose. Some points that you know, but you have to summarize it. So what is this? It is easy to understand, okay, and easy to calculate. Okay, it seems difficult, but it is telling it is easy to calculate. Actually, it is easy because you have to follow certain procedure. Otherwise, the procedures are actually, it is very easy. Neither the extreme values are needed in its computation, nor they are affected. So we don't need the extreme value, and if extreme values are anything, the value of mode is not getting affected. It can be obtained simply by inspection also. This is also a merit. We have already seen the inspection method of inspection. It can be obtained graphically. Okay, right. Then it gives the most representative value of the series. So the characteristic of mode is the maximum occurred frequency. So maximum occurred number. So that is the most representative value is the mode. Now another one is it can be determined straight away from an open-end series. So this is the method. This is the measures of central tendency which can be determined from an open-end class. It is capable of studying qualitative data. So mode can also be determined for the qualitative data. Also, its determination depends upon the frequency rather than value of the item. So mode is determined based on its frequency rather than the actual value. So that is why for qualitative data also it can be determined. It is reliable measure for studying skewness of a distribution. So whenever you want to show the skewness of your data, you can express it in the terms of mode. Then demerits. So the first demerit is not based on all the observation, because only we are taking the model values, model observation and our maximum occurred frequency, and we are determining the mode. If all the values are not known, then also we can determine the mode. It is not capable of further algebraic treatment. This is the greatest demerit, that further you cannot do algebraic treatment, algebraic calculation for this mode. In continuous and bimodal series, its determination involves many steps. So already we have seen in continuous data, it involves the preparation of grouping table, then analysis table, then again you put the formula. So this is cumbersome. It cannot be determined in a series with unequal class interval. So when class interval is unequal, then it cannot be determined by simple method or by simply taking that formula. There are other methods also nowadays. Many methods have been developed for determination of mode of unequal class interval, but by simple formula we cannot determine. Then it is not useful in the cases where it is desirable to give weight to the extreme value, because it does not involve the extreme value. So when you want to give weight to the extreme value, this method is not, this mode cannot be determined, and this is the most ill-defined average. So that you have to remember, this is the most ill-defined average or measures of central tendency. Now what are the use of mode? So it is very much useful in the field of business and commerce. How? It helps the businessman in taking decision to procure or produce items in large quantity to increase his sales and profit. So by determining the mode, you can see the mode of your demand. So if mode is coming in the month of September or October, so in that month you can procure more items or you can produce more items. Again, similarly for meteorological data, so by determining the mode of rainfall or determining the mode of temperature or whatever meteorological indication, we can predict, or it can be used for forecasting. Similarly in business or share market also. So these are the utility of mode. Now relationship between mean, median and mode. So in a symmetrical distribution measures, when data is symmetrical, we will study in our later classes. Symmetrical means when data is normal distribution. Symmetrical means it can be divided into two equal parts. So here in case of symmetrical distribution, the mean, median and mode will be equal. So mean is equal to median is equal to mode. So this relationship you have to remember. In symmetrical distribution, mean, median and mode will be equal. Then similarly, in case of positively or rightly skewed data, we have to study skewness and kurtosis in the later classes, but you have to remember, in case of positively skewed data or right skewed data means the data is rightly skewed or it is positively skewed, means less number of observations are present in the right side. So in the rightly skewed data, mean will be greater than median and median will be greater than the mode. So maximum there will be mean and minimum there will be mode. So this is again a empirical relationship between the mean, median, mode. Now in case of negatively skewed data means the data on the positive side will be more. So in negatively skewed data, mean will be the minimum and mode will be the maximum. So these are the relationship between the mean, median and mode that you should remember depending on the distribution of data. So with this I have finished the mode and probably the measures of central tendency. In the next class we'll study some new topic. Thank you very much.